or not, but I'm like constantly fighting my obsessive compulsive behavior. Okay, so let's get to double integrals. What do I have? I have, so double integrals. We have for double integrals. The subjects are x simple or y simple. So it's important for us, if it's not x simple or y simple, both of them, then we can divide the area into one simple regions, right? So that's one of it. Two is the iteration. That's change of order of iteration. Then it's just solving the double integral. So that should have been actually, yeah. And so when you get this, and then you're solving the integrals. There are questions on this sample test. Look at the sample test for dividing the region. And we'll do some on Wednesday also. So it would be a little bit of that on Wednesday. Now let's start with our first problem in here. It says find the volume of the solid in the first octant. What is the first octant? That's x bigger than 0, y bigger than equal to 0, z bigger than equal to 0. And it's asking to find a volume in the first octant for this z equal to the surface of 4 minus x squared minus y. So what should I do? Okay. First of all, let's say I don't know what that surface is, right? I know the surface is sitting up above the x, y, z. But I know z is going to be between 0 and 4 minus x squared minus y. So the height at any point on xy plane is going to be 4 minus x squared minus y. Right? The height of the solid at any point is going to be that. Is going to be given by that formula. So basically, I'm trying to take the double integral of the height. This other end is 0, so the height is going to be just that. Y dA in terms of x and y. This x and y on the bottom means that in terms of x and y. And then over the region, whatever that region is in R, in R2. So that's my goal. Now, how do I find, so there are two questions. One is, how do I find the region R, and how do I set up the iteration? The two questions in there, right? So region R, using this equation, I can tell that this is mostly positive, but I can, I'm sorry, not mostly. This is positive close to the origin. And then it becomes negative in the first octant as X and Y grow beyond a place. So basically, what I'm trying to find is where this region, I'm sorry, this surface is intersecting the XY plane. And how do I find that? By setting Z equal to 0. So the surface intersects the Z equal to 0 plane at 4 minus x squared minus y equal to 0. Solving for y gives me y equal to 4 minus x squared. So y equal to 4 minus x squared is that. I know that the region is in here, so I can shade it. And here, over here, I get the intersection of this curve with x-axis is going to be 2. 2 and negative 2 doesn't matter to us. And 4 up there. Okay, so I got the region. This is not asking me to change the iteration, right? So let's set it up the way it's easier for us. What way is easier for us? Y is already solved, right? It's the region for y is already solved. So I can set it up as y equal to 0 to y equal to 4 minus x squared. So let's set that up and see if it's working. And then x is going to be remember, x is the most outer, it's just going to be numbers. And so it goes from 0 to 2. So far, everybody okay? So how do I integrate? Oops, sorry, I forgot the dx at the end. Find the inner one. Take the integral with respect to y. What do I get? Let's put the outer one in. When I'm taking the integral with respect to y, I get 4 minus x squared is the constant times y, then minus y squared divided by 2. And I have to plug in 0 and 4 minus x squared. So now I get 0 to 2, plug in for y, plug in 4 minus x squared. This is y equal to, right? If you forget, put that in there so you won't make a mistake. So it's 4 minus x squared times 4 minus x squared minus 4 minus x squared to power 2 divided by 2 dx. And so it's integral 0 to 2. Let me write this in a cleaner way. Dx, which is integral 0 to 2, 4 minus x squared to power 2 minus half of it is just half of it. And then you integrate this one, however it is. You have to expand it. And you solve. Okay. At this point, it's fairly okay. You can take the 1/2 out still. Here. Looks better. It's just a polynomial. And you solve and you find the answer. Okay, that said, I was just solving the, put it here. Oh, heck. Now, there are a whole bunch of integrals, and I think I'm going to do 2 of them. And you can tell me, I'm going to start from A. If you have a preference, tell me. There we go. I cannot manage this, can I? There we go. So I have 4 integrals in part 2 that you can choose whichever you want. Sorry. Every time I put on mask, it's, you know what happens, right? Everything that can go wrong will go wrong. What's that? The Murphy's Law? It's just my nose starts itching like crazy, and I have to itch. Yeah. I never have to itch my nose, right? Unless I'm putting a mask on. Otherwise, never. So here I have 4 of these, and my feeling is that it doesn't tell you that, obviously, but my feeling is that if you start integrating in any of these 4 in the way that it is already, you run into trouble. So they are not methods that the methods in calculus 1 and 2 are not going to help you. That's when the integration, the antiderivative is non-elementary. So that's when you do that swiping the order, the switching the order, basically. The iteration changes. And so let's do at least 2 of these, I think. That's important to do. I'm starting with A. Tell me if you have a preference, okay? 0 to 1, x squared e to the power xy dx dy. There we go. Now it's correct. Okay. So again, if you want to take the antiderivative with respect to x, you run into scratch work. You run into x squared e to the power xy dx. And then it becomes integration by parts. And at the end of integration by parts, you end up with y squared in the denominator and e to the power something times y. So the second integration becomes non-elementary. And therefore, you don't want to do it in that order. You want to change the order, basically. So this makes this outer integral non-elementary. And the problem is not the integration by parts, but the problem is when the outer integral becomes non-elementary. So now I want to change the order because I just kind of figured out that the second integral becomes non-elementary. Let's see what order is right now. See, x, the bounds for x is given by y and 1. So x is between y and 1. X equal to y is this. And then x equal to 1 is this. And x goes right now, the order is that way. And y goes from 0 to 1. So that's the region. Now I want to change that order. The arrow that I showed you, I want to change it to another arrow. And now I want to change it into dy dx. So I put the arrow that way. Wait. I got myself confused with the colors. I think red is always the arrow. So that is the arrow is going to change that way. How is this? This is y equal to 0 on the bottom, y equal to x on top. Solved in terms of y. So I changed the order for y to be inside, x to be outside, and y goes from 0 to x, and x goes from 0 to 1. Now let's see if this is going to solve our problem a little bit better. So what do I get? I get integral from 0 to 1. Wait, let me do it right here. Integral of x squared e to the power xy dy. What is this? X squared comes out because it's constant, e to the power xy dy. And that is x squared. X is a constant coefficient for y. It would be e to the power xy over x. So I put it right here, x squared e to the power xy. This is the inner one. Over x, which is x simplifies. X e to the power xy, let's see, dx. Now that we're at this point, what's the next step? Oh, wait. My apologies. I didn't put in the bounds. So let's put in the bounds. If I plug in x, I get x e to the power x squared. If I plug in 0, I get x. Now, take the antiderivative of this. Wait, this part is a u substitute. And the u substitute will give me integral of, wait, yes, x minus 2 points to me. I forgot that dx. So it's going to be e to the power u du, but over 2. So it's e to the power 2u plus c. That's e to the power x squared divided by 2 plus c. So the first part is e to the power x squared divided by 2. The second part is just x squared divided by 2 and 0 and 1. And you find the answer. Are you guys okay? Here we go. Okay, tell me which one of these do you want me to do out of the 4? Out of the 3. I already did one, so one more left. This is out. B, C, or D. You can put it in chat. Or you can make, wait, no. How do you make, which one? Third one? Fourth one? I have one for fourth one. Chat. Which one? Are you guys? C. I have requests for C and D. Which one should I do? Doesn't matter? Okay. So let's do C. Oh yeah, I have 2 requests for C. Let's do C. Okay. So what happens here? These are very similar. This time around, as soon as I start taking the most inner integral, I run into trouble. Oh no, that's a non-elementary function. I don't know how to do it with the methods that I know. So methods, the integrals that we don't know, are more than the integrals that we do. But the more is the difficult concept to understand, because we know infinitely many integrals we can take, and we know infinitely many that we can take, but how do we make it more? So that's another question. Now, integrating, I want to change the order, but to be able to change the order, I have to figure out the region. Here it says y is between these two. So y is between square root of x over 3 and 1. That is basically x is equal to 3y squared, right? This equality is that. And then x is between 0 and 3. So x, 0 and 3. And then x equal to 3y squared. Let's say y equal to 1 gives me x equal to like that, right? Everybody fair with that? And then I have, this one says y is between this curve and y equal to 1. Y equal to 1 is here, right there. There we go. And right now, we have this order. And I want to switch it to the other way. Now, then, okay, this is better because I think that was not good. 3 and 1. And so now I'm going to go in that direction. Going in that direction, I get integral. Oh, hold on. I have to solve for x equal to 0 in this side, and x equal to 3y squared this side. 0 and 3y squared. And then the outer would be in terms of y. And it seems like y has to be going from 0 to 1. Right? And so I have this. Now I can take the integral. The most inner integral is going to, oh goodness, I got rid of the square root too. That's another bonus to this change of order, right? And so what do we have against the square roots? I don't know. It's just not natural. There we go. So e to the power y to power 3. Do you see any x in it? No. The entire thing is a constant. So treat it as a constant coefficient, then integrate with respect to x, which means that constant times x. Then set x equal to 0 and 3y squared. And so the integral becomes 0 to 1, 3y squared e to the power of y to the 3 dy. Right? Now, this is a beautiful u substitute. This funky business, let me think. The funky business of these double integrals and triple integrals comes back if you are studying different probability distributions in a ton of ways. So yes, it comes back in Math 526. That's one place that most of you guys have to take. But also in business side of the story, this double integral, triple integral, and that comes back to, because you want to look at the probability of things happening, basically. And so that's I don't know. I just felt like I should make a commentary there. So integral of 3y squared e to the power y to the third dy is going to be integral of e to the power u du, which is e to the power u plus c. It's e to the power y to the 3 plus c. And so e to the power y to the 3, 0 to 1, and e to the power 1 minus 1 is the answer. Are we good? Okay. So, yeah. These are becoming easier on you guys, aren't they? Just, now I'm getting rid of this. I will need that one. Don't get rid of it. Note to myself.